So welcome to all. I am Dr. J.Immanuel Durai Raj. So Assistant Professor in St.JOSEPH'S of Technology. Today I am going to explain a pneumatic circuit design method. It's called CASCADE method. So it is a simplified method of all the different methods that is available. So I am going to teach today. So before that we will learn some basics of circuits, valves, and go into the circuits. So for designing a pneumatic circuit, so we will have four basic requirements. First one is safety of the operation, second one is cost, third one is efficiency, fourth one is performance of desired function. So I will repeat. First one is safety you should not compromise on safety. Second one you should go with the efficiency. Third one, performance of desired function, and cost. So these are the four parameters that have to be considered. Okay. So even though we have different methods, so cascade method is simplified method that you can easily understand the different concepts. So why we have to design a pneumatic design of circuits? Okay. In each and every machine or component or equipment, so you will have different cylinders will be available. So you can see a JCB. You will have different 4 to 6 to 8 cylinders will be operating with the help of a single pump. So from the single pump there will be a single valve will be there. So valve should control all the other cylinders. So our aim is to minimize the complication of connecting different cylinders with the use of cascade valve. That is our main objective. Okay, that's what the cascade method deals about. Okay, for each and every cylinder we require some minimum basic some equipment. So what are the equipments we require? I will explain one by one. First we will go with the basic components. Basic component of cylinder. Take a double acting cylinder. This is a double acting cylinder, a pneumatic symbol. Okay. So the double acting cylinder, this end is called piston and this will be called rod end. Okay. So other name for double acting cylinder is called differential cylinder. Differential cylinder. Why it is called differential cylinder means can see the area available in the piston end will be greater than the area available in the rod end because of some area will be occupied by the area of the rod. Okay. The space obtained by the fluid to push the piston end will be greater than the fluid which is obtained. The space here is lesser. So this is called differential cylinder. So similarly, double acting cylinder, you are having single acting cylinder, you are having telescopic cylinder, tandem cylinder, dual cylinder. So many cylinders are there. So normally generally uses double acting cylinder. Okay. So another what are the other elements required for cascade design method is, so we need some limit switches. So this is a mechanical limit switch. So this is similar to the 3x2 direction control valve. So 3x2 direction control valve. We are having so many direction control valves are there. So 2x2, 3x2, 4x2, 5x2, lot of valves are there. So here we are going to use 3x2 valves with the limit switch for application. This is spring return limit switch. Okay. So then we have one direction control valve. This is a 4x2 direction control valve. 4x2 means 4 ports and 2 positions. 4 ports means 1, 2, 3, 4. So there is 4 ports, 4 way will be there to move the fluid out and in, and can operate 2 positions. So this is called 4 ports and 2 positions. Okay. So this cylinder plus minus refers to plus means if you are sending the high pressure fluid here, this will be extended. If you send high pressure fluid here, this cylinder will be retracted. So that's the meaning of plus and minus. Okay. Here you also are given the name A1, A plus means once the cylinder extended, this will hit during the extension. So this will be get energized when cylinder extended. That is plus means extension, minus means retraction. That's what we are referring. Okay. So this is a 3x2 limit switch, spring return operated. So here you can see plus minus. That means if you want to push the cylinder extension mode, you have to send the fluid through this way. You have to make the operation in this port. If you want to make retraction, you have to send the fluid to this right mode. So that is a minus means. Okay. Then we need additionally 2 pressure lines. Some pressure line is needed based on how many cylinder we are using. Pressure line required, how many cylinder coming. Then we are having some group changing valve. It is also one of the direction similar to direction control 4x2. Okay, this is called group changing valve. So other name for this valve is called cascade valve. So the head is cascade. So this valve will call cascade valve. That is, it will change the group. That's what the basic elements required for cascade valve. So now we see what are the rules and regulations to frame a cascade method. Okay. So suppose example. So one example is given to generate a pneumatic circuit for A plus B minus A minus using cascade method. So what is A plus B plus means? So A and B are representing cylinder. A is one cylinder, B is another cylinder. So A plus means A cylinder has to extend. Then B plus means B cylinder has to extend. B minus and A minus. So take the case of example of some drilling and clamping. So drilling means A has to extend for drilling. Then so B cylinder has to extend for clamping. Then the clamping has to be removed. Then drilling will be removed, or piece will be removed. So this will be the operation they will give me, extension and clamping, retraction like this. So that's the meaning of extension and retraction. So A cylinder extends, B cylinder extends, B cylinder retracts, A cylinder retracts. This is what the operation that is given for our problem. So we will see what are the rules, what are the elements, how to calculate the elements required for this. Elements what I mentioned previous year is how many number of elements which is required. Previous slide I have shown. Number of direction control valve required. So number of pressure line required. Number of cascade valve required. So these are things you have to calculate before going to the problem. Okay. So now it is given our problem is A plus B minus A minus. First one is you have to form a group. So if you have 2 cylinders, 3 cylinders, 4 cylinders, 6 cylinders, you have to take this in the single smaller groups. So to frame the group, we have some rules. To frame the group, we have some rules. One rule is in every group, letter should not be repeated. That is, same cylinder should not be repeated. Okay, that's the main rule for forming a group. Okay. So now I am going to start the rule here, form group here. First I am going to write the A plus here. Then I am going to write the B plus here. Then I can write B minus here means, so I am violating the rule. So this B cannot be in the same group. So no letter should not be repeated. B and B should not be repeated. So I am stopping A plus B plus as a first group 1. Then I am starting the next group 2. That is B minus and A minus. So no letters are repeated here, and this is called group 2. So group 2. So here I am not violating the group forming rules. That is, letters are not repeated. So we are having 2 groups, group 1 and group 2. Now you have to find out how many pressure line required. So number of pressure line required equal to number of groups minus 1. That's the formula rule. So we are having 2 groups, one group and another group. So this group 2 groups are there. Then number of limit switches. So the previous slide you have seen, each cylinder requires 2 limit switches. So in this case we are having 2 cylinders A and B. So 2 cylinder requires 4 limit switches, each 2. So 2 into number of cylinders. So 2 into equal to 4. Okay, you are having 2 cylinders. So 2 into 4. Then you have to find out number of direction control valve. So each cylinder requires 1 direction control valve. It's 1 direction control valve. We are having 2 cylinders. So we need 2 direction control valves. Okay. So last one, number of group changing valve, cascade valve. How many group changing valves are required? Okay. So that is comes under number of groups minus 1. So we are having 2 groups. So 2 minus 1, 1. So 1 group changing valve is enough to control all the other different valves like this. Okay. This is what the basic formula before starting the cascade method. So if you are doing any mistake, you cannot proceed further and end up with different connections. So you should be careful on creating this. Now we go to the circuit design. Okay. So now you draw the basic circuits components. Now already based on the formula, the first slide you have shown. Based on the formula, I required by A and B 2 cylinders are given the problem. Each cylinder requires 2 limit switches. I have drawn 2 limit switches. One is left side and draw it in the somewhat the right side. Similarly, another 2 limit switch for the B cylinder. Then you draw a DC valve, direction control valve for each cylinder. Here and another cylinder for DC valve. Then you go for 2 pressure lines. Okay, we have calculated here. This pressure line 1, pressure line 2. So this is for group 1, this is for group 2. So draw 2 lines. Then you draw a group changing wall, cascade wall. So similar to this. Yeah, you give the name like this. For cylinder give A and B. So and also mark which is going to extend plus minus. Okay. Then you similarly mark A minus. For A cylinder give A minus. That is during interaction this will hit. During extension this will hit. Similarly for B cylinder you write B minus and B plus. Okay. So during interaction of B cylinder this will get energized. During extension of B cylinder that B plus will get energized. Okay. Similarly you give the name VA, valve A. So for dash control valve A. For B cylinder valve B. And this will be plus and minus. Since it is pneumatic, so you are drawing a symbol. There is no reason why it is going as a bend. You put a small dotted line like this. That is, it is going into the bend. Okay. Now this is a high pressure line. You can see there is a difference here. The pressure line here and here. So normally the cylinder will experience some external load. It has to do some load. So it needs more high pressure fluid inlet, pneumatic air inlet. So this will be a different inlet, and inlet for this pressure line will be different. This will be lesser, low pressure line. So this pressure line, cascade wall, the limit switch will be operated by low pressure line, and this only the DC wall will be operated by high pressure line that is given as in a small circle. Okay. Then this DC wall what you are using is a pilot operated DC wall. So many DC walls are there. So we are having manually operated, lever operated, pedal operated, solenoid operated, electrically operated, so plunger operated, cam operated. So many walls are there. So in this case, since you are going to move our DC wall using the pneumatic fluid itself, what you are using, so I am going to choose pilot operated DC wall. Pilot operated DC wall. So it is mentioned here, pilot operated DC wall. Okay. Then, so as per the rule, there are two pressure lines on cascade wall. Now my task is I have to go with A plus, B minus, A minus. That's the task is given for us. First, I have to provide the provision A has to extend. Then I have to provide the provision B has to extend. Then B has to retract and A has to retract. That is what my provision I have to give. So what I am going to do is, initially I am going to actuate the cascade wall manually. Manually I am going to actuate the cascade wall while starting the machine. Okay. While starting the machine I have to manually actuate. So the line will go and occupy the space. You can see how it fills. So you mark it, one pressure line is group 1 and another pressure line is group 2. One pressure line is group 1 and another pressure line is group 2. Okay. Then from each group, so you know A plus, B plus comes under first group, B minus, A minus comes under second group. A plus means you can see the limit switch A plus and this B plus. Okay. So you connect directly, as I see the yellow line, directly connect to the limit switch here, limit to DC limit switch here, but it cannot pass, so it is locked here. It is a locked condition. So A plus also connected, say this is the dummy connection, but once it is energized, this will pass. Okay. Similarly, the group 2. So group 1 also is connected here. So A plus, B plus limit switch are connected. That's the first. Second, group 2. Group 2 you can see B minus, A minus. Here is a B minus and here is an A minus. So you connect the blue line. So from group 2 you give a dummy line to this A minus and B minus. This is a blue line. See the blue line is connected. Once it is energized alone, it will work. Okay, this is what the connection. So I given the pressure line. Once I give the low pressure line, this will be filled up. First phase group 1 will be filled up. Second phase group 2 will be filled up. Okay. So this is what the arrangement. Now we will see how to connect. Initially I want to make A plus. Even when you are starting the switching on your machine itself, my A has to extend. That is my objective. So you give connection like this. You can see this black line. Now once cascade wall is operated, Now the group 1 pressure line is get energized. That is, the fluid will be low pressure fluid will be low pressure pneumatic air will be filled here. So since I am giving direct connection from here, so this low pressure line will go on pilot operated DC valve. Now the port will change to left mode. Okay. So this port will come to here. This portion will come to here. So the high pressure line. So this is low pressure line and this is high pressure line. High pressure line will come here and here to here, here to here, here to here, and move to the here and go to the piston and other cylinder. Now the piston and cylinder extends. Piston extends because of direct connection from group 1 to valve A. Now valve A extends. Valve A extends. Once it is extended, this will hit the A plus. This will hit the A plus. Okay, once it is hits A plus, this is spring actuated, this will get energized. The will be pushed down. Pushed down. So the yellow line, you can see the yellow line, this will be connected to here. And here and goes, there will be goes connection. Once A plus over, B plus has to be carried out. Once A is over, B has to be carried out. Okay, so I have to support, this limit switch has to support to actuate B plus. So it is this line, black line, see here, goes and goes to DC valve. DC valve. Now this will change the position. So this will shift to the right mode. The high pressure line here will move to from here to here, here to here, and here to the piston of the B cylinder. Piston of B cylinder. Now B cylinder extends. B cylinder extends, and we hit the B plus. We hit the B plus of limit switch. Small B plus. Yeah. Now what happens? Once A plus over, A cylinder extension over, B plus extension over. After this, B minus has to occur. Before that, it has a slash. That's the group is over. So the rule is once the group is over, it has to go to the group cascade valve. Okay. So that is the cascade valve. So the output of this B plus has to go to the cascade changing valve. You can see here. The output of the B has to go to the cascade changing valve. It should not go to the B minus. It should not go to the B minus here. It has to group has to be closed. Yeah, closed. Once it is closed, the position will be moved, shifted to left or right. Now all the fluid that is in the group 1 low pressure fluid will go out and go out. Now group 2 will be energized. Group 2 will be filled with low pressure fluid. This will be energized. Okay. Now what happens? Now B minus has to occur. Once the group has to change, B minus has to occur. Yeah, B minus has to occur. See, now we are connected. This is what the group changing valve. So all the fluid there is has to go out and this will get charged up. This group 2 has to be charged up. Once B minus means here. You can see from group 2 the red line. You can see from the group 2 directly the valve minus is connected. Okay, once this low pressure fluid filled up, it changes the original position. That's the original position. Now the high pressure fluid go from here, here, here and goes to the rod and other cylinder, and rod and will be retracted back. Once it is retracted back, this will hit the B minus. This will be the B minus limit switch. Now B minus limit switch will get energized. B minus limit switch get energized, and the output of the B minus has to support A minus. So that's what the objective. The output of this cylinder will go to the A minus. You can see once it hits, this output has to be given to A minus. Output of the A minus. You can see the cylinder. The output of the output of this B minus has to be given to, you can see here, is given to A minus. Okay, the output of the B minus is given to A minus. So once you are drawing the line, you should be careful that you should not cross the line. Instead, you can put a hurdle like this. So it is electrical, similar to the electrical circuit. This is a pneumatic circuit. So you put a small bump like this, so it should not cross. So for all the lines you can see, you have to draw like this. Then it will go to A minus. Now it will go to original position. It will come to this position. Now high pressure fluid will move to here, or another cylinder, and this will be retracted back. Okay. Now this will hit A minus. So what will happen after A minus? After A minus, the group overs. So as I told, what we should do is so what I told is after A minus, group has to over, so it has to go to group changing valve. Now once the group changing valve is actuated, so this process will stop. Either the process will stop or you can reactuate the process. This low continuously it can work. This is what is cascade operation. So what we should know is at any stage you should not change your sequence. A plus, B minus, A minus. At any stage you should not change the sequence. Okay, one. And you should see that the operation should not get disturbed. That's what the main objective. Okay. So now we will recap what I have given already here is. Okay, I will recap what I quickly refresh what I have given is. So in the cascade method, so you have to have some set of rules. You should follow some set of rules. How many pressure lines required? How many DC valve required? How many release switches required? How many cascade valve required? That's the 4 things you have to remember. Before that, you have to form the group. For forming the group, the rule is in every group the letters should not get repeated. So A should not be the same group. A plus and A minus should not be the same group. Similarly, B and B plus should not be in the same group. Similarly, C and C should not be. N number of cylinders you can use. Okay, that's what the main group. Okay, so this is a double acting cylinder we are going to use. Each cylinder requires 2 limit switch. So 3x2 limit switch we are using 3 ports and 2 position gas stack. 3 ports and 2 position. Then we are using each DC valve, 1 DC valve for each cylinder. That is what requirement. Then 2 pressure lines. So this is a pressure line. A pressure line is required to actuate your cylinder. Then you are having group changing valve. So change your group. So I told you are having so many number of cylinders you are having. The cylinder has to be grouped. So this will be master. Take is a master valve. So pressure line will be different. The cylinder will be actuating the different higher level pressure, and this pressure line and limit switch will be actuated by low pressure line. So that's what you should understand. So this is a high pressure line, this is a low pressure line. This is what the basic elements required for a design of cascade limit. So all what I have already seen. Okay. Now in the problem what is given is A plus, B minus, A minus. So now you understood what I told earlier. Okay, what you have to do. Okay, so you have to form first you have to form a group. Second, pressure line. Third, limit switch. Fourth, direction valve. Fifth, group changing valve. These are the 4 5 things you have to form before starting drawing a cascade valve. So my task is given A plus, B minus, A minus. Then I have to form the group first. So I am starting in the group A plus and B plus. So I cannot add B into here. So I am starting as a group 1. Then I am starting the next group B minus, A minus. So now this is group 2. So you can see I am not violating the group rule, that is no letter should be repeated in the same group. There should not be any A, there should not be any 2B. 2 letters of A should not be there. 2 letters of B should not be there in a single group. I am not changing the sequence also. At any point at time I should not change the sequence. Whatever the given the sequence should be here also. So that's the main objective. Then to calculate pressure lines, number of pressure line equal to number of groups. If you have 2 groups, we need 2 pressure line. Then for each cylinder we need 2 limit switch. What is in earlier elements. So number of cylinder into 2. So totally we need 4 limit switch for 2 cylinders. Then number of direction control valve. So since we are having 2 cylinders, we need 2 direction control valve. Then number of group changing valve. So it is the number of group minus 1. We are having only 2 groups. So 2 minus 1, 1. We need 2, 1 group changing valve. These are the main things what you should calculate before starting. Okay. Now initially you draw the basic elements. So in exam, you draw in the landscape manner, take the landscape, so don't put in the portrait. You draw in the landscape page, so draw 2 cylinders and draw 4 limit switches and draw 2 direction control valves. So as per the requirement formula, 2 pressure line and 1 group changing valve. So draw initially with the scale. So don't use the pen to draw this. If you have any problem, you have to redraw. It will be difficult. So use pencil only to draw initially. Nowadays, software is also available to draw this. Automation Studios is software available, but you should manually know how to design the circuit. Then only you can create the Automation Studio software. That's what my theoretical learning here. Okay. So my sequence is A plus, B minus, A minus. So A plus has to start first, then B plus, then B minus, A minus. Okay. Once I am switching on the operation, this cascade and pressure line comes under low pressure line. This valve A and valve B comes under high pressure line. So this is a separate line, this is a separate line, this is a separate line. So once I am manually switching on this cascade valve, the low pressure line will occupy group 1 or group 2 and it will get actuated. Okay. Now A plus has to be carried out. You can say I am going to give the name group 1 and group 2 for these 2 pressure line. Group 1, group 2. Then, and from group 1 you give a dummy line. So A plus, B minus, A minus. That is A plus, B plus, here B minus, A minus. So it is represented here. So from group 1, A plus, B plus is there. From group 1, the yellow line. B plus give a dummy line and A plus give a dummy line. So dummy line means once it is energized only this will actuate. So similarly, group 2, B minus and A minus, see the blue line. From group 2 I am giving a dummy line. Anyway, it is not energized, so until now, group 2, the blue line. You can see B minus is given, the dummy line is given. Okay. Once switching on occurs, now A plus has to start. See how it is going to connect. So once it is switching on, the group 1 is getting energized. Group 1 is getting energized. So it is filled with the low pressure here. So directly, see the black line is connected to VA. So once you are switching on the cascade valve itself, now the VA is going to operate. That is, the port here is to change to the left mode. Okay, already it is showing that all the cylinders are in inactuated mode. That is retracted mode and you have to draw. Now it is changed to left mode. So this line is go to piston end, this will extend and this will be A plus. Now A plus has to support B plus. A plus has to support B plus. So directly this output of the A plus will go to the VB. So now VB will change the position to left mode. Now the high pressure line will go to the piston of the B cylinder and B will extending. So once B extends, you can see the groove has to change. Groove is over. So B extends, this will be the B plus. Then output of the B has to give the group changing valve. It is given. Once the group is over. So now group is over means this should shift to the left mode. Initially you have here, now the change in left mode. Now what will happen? All the pressure line in the group 1 will be evacuated, go to the vent, and group 2 will get energized. That is, low pressure line is filled up. Low pressure line is filled up. Okay. So now you can see all the fluids are going out. So now group 2 is filled up. When the group 2 is filled up, B minus has to directly occur. So give a direct line from the group 2 to B minus. B minus, the pilot operated. Now this will be shifted to original position. Now the high pressure line go to the rod under the cylinder and this will be retracted back. Once retracted back, this will be the B minus. So the B minus should have A minus. You can see the output of B minus should go to the A minus here. It has to come to A minus here. So see here, the output of B minus is go to the A minus here. So now it the A minus. Now this will get the fluid goes here and this will be retracted back. So A minus occurs. Now once A minus occurs, group is over. Group is over. So group over means from A minus, this will go to the cascade valve. This will go to the cascade valve. So now the operation over. Okay, this was the simplified form of double electric cylinder in the cascade method. I hope you understand the video very well. Okay. Thank you. So welcome.